Hello everyone, my name is Vipra Joshi and I am an assistant professor in St. Andrews Institute of Technology and Management in Electrical Engineering Department. Today I am going to deliver a lecture on subject of control system engineering. In this video, I will be explaining introduction to time analysis and we can say it time domain analysis. This is unit 3rd topic of 6th semester in electrical engineering branch. In time domain analysis, the response of a dynamic system to an input is expressed as the function of time. It is possible to compute the time response of the system if the nature of the input and the mathematical model of the system are known. By this, we can get the response of the system. Usually, the input signal to control system are not known fully ahead of time. For example, in the radar tracking system, the position and the speed of the target to be tracked much vary in random fashion. It is therefore difficult to express the actual input signal mathematically by the simple equation. So that's why we are studying the time domain analysis. We can say it is very important for the control system because whatever the signal we are going to consider in the time domain analysis and time response analysis, these signals are very according to the time and with the time. So here we have input is RT and output is CT. So all those which we are taking with respect to the time. That's why it is very important. In a block diagram and Mason gain formula, we take input and output in frequency domain. Okay, so here we take these input in the time domain. So that response means the output of the system. So time response analysis is a variation in output of the system with respect to the time. It means the variation is denoted by the with respect to the time, which variation is occur at the output. Okay, so it means if time is varying, then what will be the output we find here. So we can say time response analysis of the system means as to how a system behave in accordance with the time when the specified input is test signal we applied. Okay, so what are the behavior of this system with respect to the time if we are uh, applying input test signal. This test signal can be unit impulse signal, unit step signal and unit ramp signal. So by this we can study and stability and accuracy of the system. With the time response analysis, we can study stability and accuracy of the system. Time response of the control system. Time response of the dynamic system is response to an input expressed as the function of time. So here we have this input and here we have this input, and when we applying this input for the system, here the output will be variate with respect to the time. So here we at first we applied the input is this nature and output is this nature. So there is a variation on signal. So we will study here the variation of time with respect to the the variation of signal with respect to the time. So here we are having two type of response. First is transient response and second is steady state response. So at first we will discuss what is the transient response. Okay, so any control system, it will be having energy storing element in it, like capacitor and inductor. These are the energy storing element. So by these element any control system is making. Okay, so any control system, these elements are having. So these are the storing element, then energy of complete control system distributed, and it take some time for the system to go from the state 1 to another state. So this time taken by the system to change state is called the transient response. So we can define it as that part of the response that goes from initial state to final state, and we can say that the time required to change from one state to another state is known as transient time, and the value of variable which is changing in this period is called the transient response of the system. So, which time required from going to initial state the final state, it is the transient time, and in between transient time the value of variable which is changing in this period is called the transient response of the system. And the second is steady state response. Steady state response, it is the fixed response when time reaches to the infinity. So steady state is not changing with the time. That means response of steady state is fixed. If we see in this figure, from here to here, this is the transient response. That means this is the transient response which is vary with the time, and this is the steady state response. That means response of the steady state is fixed. So we can observe here, if we are increasing in the time, response is also vary. Here horizontal axis denoted to the time and vertical axis denoted to the response and output. So if we are increasing in the time at horizontal axis, then response is also vary at vertical axis, but in steady state response is not going to vary. Here we can see that the steady state response is not going to vary, so it is the constant. So this is the transient response and steady state response. The variable response is known as transient response, and the constant response is known as steady state response, which we get at the infinity value. Okay, so here the input is the step input which we apply. So when the response of the system is changed from rest to the equilibrium, it takes some time to settle down. When the response is going to here, then it is takes some time to settle down. Okay, so transient response is the response of the system from rest to the equilibrium to the steady state, and the response of the system after the transient response is called the, here after the transient response, the response of the system is called the steady state response. So we are going to discuss the test signal for the transient analysis. Okay, so we are using some input test signal to applying these input to the control system. So here we have a standard test signal which we are applying to the control system, and we are analyzing their output for various input. But this will be see in next slide what are the input for here which analyze the response for the control system. So by this we will see the accuracy and stability of the system. So the characteristic of the actual input signal are sudden shock and sudden change, and a constant velocity and a constant acceleration. The dynamic behavior of the system is therefore judged and compared under application of the standard test signal. Standard test signal is unit impulse signal, step signal, constant velocity and constant acceleration. So another standard signal is a great importance in the is the sinusoidal signal. First test signal is unit impulse signal. This signal is denoted by delta t equal to a at t equal to 0, and at t not equal to 0 it is 0. So here if you see that here it is denoted by the t horizontal axis, and this is denoted by the vertical axis denoted by the delta t. So here at the value of a, this is the amplitude of the signal. So here we can see that at the 0 the value of this is a, and after when t is not equal to 0, then the value here and here the value of impulse signal is 0, and we here we put any value at a because this is the magnitude. So here we can apply 1 2 3 4, so this is the constant value. So we can say the impulse signal giving the value at the t equal to 0. Okay, so impulse signal, the property of the impulse signal is always equal to 1 when t equal to 0. So it when t have any value other than 0, then it gives the value is 0. This is the impulse signal. Now the second signal is the unit ramp signal. In this signal, the property of this signal is the value of ramp signal is at for t greater than equal to 0. Here you can see that for t greater than equal to 0, the value of ramp signal is at. The slope is like proportional to the t, and a is the constant. So this is the slope of linear, like. Okay, so here for the t less than 0, the value of signal is 0. So it is defined by the rt equal to at for t greater than equal to 0 and 0 for t less than 0. So here we can see here the ramp signal with the slope a and the unit ramp signal. When a equal to 1, if we put the value of a equal to 1, this is called the unit ramp signal. And also here if we put the value of a equal to 1, this is the unit impulse signal. Okay, so here we can see the both the graph for t equal to a equal to 1 and for the slope of at. So this is the ramp signal, which is denoted by the rt equal to at for t greater than equal to 0 and 0 for t less than 0. Now the next signal is unit step signal. In this unit step signal, the value of signal is a at t greater than equal to 0. If we see in the graph here from 0 to t, the value of ut equal to a. This is the magnitude of a, and if we put the value of a equal to 1, this is called the unit step signal. So we can see here for 0 to t, when t is greater than equal to 0, the value of unit impulse signal is ut, and for t less than 0, the value of unit step signal is 0. For the positive value, the unit step signal giving some value, and for the negative time, this give the 0 value. Okay, so these are the our test signal which we applied to the system to for studying the time response analysis of the system. Next signal is parabolic signal. The parabolic signal imitate the constant acceleration characteristic of actual input signal. If we see the graph of the parabolic signal, it is like that. Here t is the time and pt is the output of the parabolic signal with respect to the time. So here the slope is like that. So here the value of this curve is at square upon 2 for t greater than equal to 0. Here we can say the value for this is for t greater than equal to 0. So for this the value is at square upon 2, and for t less than equal to 0, less than 0, sorry, not equal to, it is the 0. So this is defined the parabolic signal. Okay, so when we put the value of a equal to 1 in the parabolic signal, it is called the unit parabolic signal. And here the value of a is 1 2 3 4, like in all signal. Okay, so these are the signal by which we can analyze the behavior and accuracy of the systems. So when we are applying these signal to any control system, then there is some response at the output, and the signal is different from the input signal. So how this signal will be changed by the system, we can analyze here. So here at first we study what is the transient response. Okay, so when we study any signal with respect to the time, and we can say whatever signal we are going to consider in the transient response, this is vary with the time. So we are studying here that type of signal. So these are the two type. First is transient response and second is steady state response. And when time is taken by the system to change from one state to another state, when time is changing, okay, so in this time the signal is varying. This is called the transient response, in which the signal is varying. And where the signal is not vary, it is the constant, it is not going to vary with respect to the time, is called the steady state response. When we are increasing in the time, the response is also vary, but in steady state response the response is not going to vary, it is constant. So these are the steady state response. After that we had study what are the signal we applied for the system. These are system are unit step signal, unit ramp signal, unit parabolic signal, okay, and unit impulse signal. So I hope you have understood the topic. Thank you.